right? Positive charge possessed by proton, negative charge possessed by electron. What are the charges for both? What is charge of electron?
1.6 minus 1.6 into 10 to power minus 19 cool.
And if I ask you proton,
Plus 1.6 into 10 to power minus 19 cool.
same value with the plus sign.
Yes.
Okay. Now, how do we create positive charge?
Removing electrons.
Yes. When there is a deficiency of electron in a body, it becomes positively charged particles or positively charged body. When there is an excess or gain in electrons in a body, it becomes negatively charged. So unit of current,
Amperes.
Here,
ampere. And unit of charge,
Coulomb.
Coulomb.
coulomb. Quick, I want quick answers. 1 coulomb, sorry, 1 ampere equals to?
1
1 Coulomb by 1 second.
Yes. 1 coulomb by 1 second. And how to define 1 ampere?
1 coulomb of charge flow in 1 second of
Very good. Okay, what is EMF?
The
Electromotive.
electromotive.
Electromotive force. What is it? What is the work of it?
Sir, it helps the conventional flow of charge.
Yeah. Okay, so what is quantization of charge? Q equals to NE is the formula.
Any.
Q is equal to NE.
Yes. So how do charge behave in solids? That is especially in metal conductor. How do charge
Move
behave
freely.
in it moves freely because it has free
Electrons.
Free
electrons
electrons.
in its outer orbit. Okay, in electrolyte solution in liquid, they are ions in that. And gas is insulator generally.
Until very high voltage is passed.
Exactly. Okay. How do charge originate? By
Friction, conduction, or induction.
induction. Yes, friction, conduction, induction.
Induction.
Induction process. This is also induction process. What are properties of charge?
Sir, they are
Additive-
unlike charges attract, like charges repel.
Yes, and they are additive in nature. Conservation of
Charges
charge.
are quantized.
Conservation of charge, quantization of charge,
Hmm.
inverse of charge.
Invariance of charge. That means they never change. They will be same charge. Positive will be positive in a closed system. They will not vary. That is invariant. What is Coulomb's law?
Sir, a force is directly proportional to the product of charges and inversely proportional to the square of distance between them.
Square of distance between them. Yeah. These are some numericals. What is potential difference?
Work done to bring a unit positive charge from
Infinity to zero.
point inside
One
the magnet.
one point to another point. Yes.
Yeah.
Okay, when we say infinity to this one, that is electric potential. Potential difference means between 2 points. Electric potential means between infinity and a point. That's the small difference. That's it. What is unit of potential difference?
V, voltage.
Voltage. And 1 volt, how to define 1 volt?
Sir, when
Joules per coulomb.
1 joule of work is done to displace 1 coulomb of charge,
From,
then point A to B.
Yeah.
From infinity to 0.
yes. So last topic of this chapter we are going to finish today. Then we'll start light chapter. Have you all tried the question which I gave you as a PDF?
Yes, sir.
Till now I will send 2 PDFs.
Sir, Google Classroom.
No. In a WhatsApp group. I didn't send in Google Classroom till now.
Sir, you can send pictures, sir, but PDF.
Yeah,
I can't
pictures.
see.
Pictures, I think so. I don't know. Pictures or PDF, I don't remember.
Pictures, sir. You sent 3 pictures.
Okay.
Even I sent you those solutions.
Yeah. Okay. Now here next topic is groupings of cell. Grouping. Now till now we were using one cell. If there are 2 cells, what will do? That's what we are going to see. First one. Series grouping. Now, when we are before that, I'll tell you one more thing. Every, I don't know I said or not, but every battery has internal resistance. Okay. Example, if I take your phone battery, simple examples. Your phone battery. Initially, when you bought, it will give you like a suppose 19 hours battery backup. Okay. So once you start using, you play games or you watch movie in that, and you keep using and again charge, again discharge, like you keep using for 1 or 2, 3, 4 months, then it won't give 19 hours exactly. It will give some more 18 hours or 18 and a half hours. It will keep reducing. So what's happened that initially the resistance, internal resistance of that battery was some R. Now it keeps increasing by time. So internal resistance always keep increasing by time. But that for our calculation, we are not going to consider that way. So here we are going to consider internal resistance R, whatever it will be very, very small. Voltmeter, do you remember that? Voltmeter has high resistance, ammeter has low resistance. This is EMF E, n number of cells, they have internal resistance small r, all are same values. External resistance capital R. Current flows I. So let's write something here. N identical cells, each of EMF E and internal resistance R are connected in series. So net EMF equals to N by E, because all E are same. See, if all these batteries values are different, if it is 1, 2, 3, 4, then it will be, we need to add those. But here all are same, so we're just taking it common. Now net internal resistance, they are N times of R, because internal resistance values are same. R. All values are R.
I didn't understand. Can you repeat again?
Yeah, 1 second. Just let me finish this writing. I'll repeat again. External resistance is capital R. And after combining, we will get this. This value is for this one. Okay. So I equals to V by R.
So what is this 3, sir? Like E.
It is E, EMF E.
Okay.
EMF means energy voltage. Same thing, voltage. In voltage, we have energy, right? Electromotive force. That is EMF. Okay. So in series, if there are n identical batteries or cells, they are identical means same values. E, all are E, whatever value it is. E is the common. In that they have internal resistance as R. Each values are R, and each value of battery is E. So total EMF will be n times of E. If I add E1, E2, E3, all are same, all are E. So E plus, E plus, E plus till N. It will be till N. So total will be unitary method, E N times E. So same way, internal resistance, they all are in series. So in series, for internal resistance, we add, right? R plus R plus R plus so on. It will be N times of R. So we wrote here NR. External resistance, capital R. We have only one here. If it is 2, then we'll do that follow-up. If I add one more resistance here, so we will combine this by parallel method, then we will make it 1. So after this, we have net EMF as NE, net internal resistance as NR, and net resistance, external resistance as capital R. Internal resistance small r, external resistance capital R. So I equals to V by R. So here V is N times of E. R is not alone here. R plus NR. Total resistance R plus NR, because they both are in series. This battery and this one are in series combination. So we are adding it, R plus NR. NR is total internal resistance. Capital R is total external resistance. Everyone, are you able to understand?
Yes, sir.
Others?
So can you explain?
Yes.
Yeah, sure. See, in short here, what are we doing? We are combining resistance and batteries. Then we need to find current. Main purpose is to find current. So for finding current, what we need? We need voltage and what we need? We need
Resistance.
voltage and resistance. So here resistance, here we till now we were not considering internal resistance of battery, but now we are going to consider internal resistance of battery.
Yes.
So we are adding all external resistance and internal resistance, then all the batteries. Here they are in series. So resistance in series, we just simply add, right? R1 plus R2 plus R3.
Yes.
Same thing we are going to do here. In parallel, you try. What will be here there for parallel? Come on, try everyone. Try for parallel, then I'll start writing. Follow same method. Just one thing changing, that is diagram. They also have internal resistance R and cells. Yes.
So is it N square E by R plus R?
N square will not come here, dear.
Like considering NR is equal to R by N.
If you
Or
forgot,
parallel connection
for
is
parallel, voltage will be same, right?
yes.
Right?
Okay, so it won't be NE.
It will be just
It will be
E.
only E. So
Exactly.
NE by R plus R.
Wait. And E by, how did you add this one then? Resistance, it is not same, only voltage is same. So resistance will be 1 by R equals to 1 by R plus 1 by R plus 1 by till N. So it will be N times of R. So R will be R by N. One plus one plus one plus one plus one till N times. So if you want me to write like a previous answer, sorry, previous explanation, I will write that. Net EMF will be E net internal resistance equals to R by N, and external is R. So I equals to E by R plus R by N, so which is N times of E and R plus
Plus R.
R. Now, what is the difference we are getting here? Done writing? Shall I write one point in both? Everyone done writing? Combined form is like this. And R, E, capital R, current flow. Okay, one important point. Cells are combined series electric current to R external resistance only if it is very large. And same point here for parallel, only if it is very small. We required small resistance, right? R is small in this parallel, R is large in series, right? You remember that, right? Or not? In series, we are adding directly, so resistance will be increasing. In parallel, we are adding, but it is in reciprocal. Reciprocal of those resistance we are adding, so it will be smaller than the smallest. Right here also that same point, but change it to very small. Instead of series, right here parallel. Remaining same thing. Actually, this is specially for competitive exams, whatever competitive exam you are going to give, and ICSE board. CBSE board doesn't have this. Okay, done writing? Yes? No?
So 1 minute, sir.
Okay.
So done.
Okay. What about others?
Sorry, sir.
Done writing?
Yeah, sir.
Both
Yes.
points? I didn't finish this one. This I kept for you. Udbhav, Sai Akshit, Aditi, are you there?
Done, sir.
Okay, Krishna, very good.
Sir, what is the last point?
Last point is same as our previous point. This one, just change instead of series, make it parallel. Instead of very
Parallel.
large, make it
Very
very
small.
small, because in parallel resistance is very small.
Yes.
So then we will mix it, like a series we study separate, and parallel we study separate. Now we are going to mix it. Now you guess for mixing. What we'll do in mixing? Any guesses? Think. Till then I'll just make a heading. Think and tell me. If you thought of anything, any idea, you can tell me. Let's see till where you can go. Come on, think.
Converting series to parallel and then finding it.
Okay, how will you try this? Give me some formula, make it something. Mix and tell me. Yeah, no problem. It's okay. Right, wrong
LCM.
doesn't matter.
So we have to do LCM.
Okay. Who's LCM?
That parallel connections.
Okay,
So we can add them.
we can add them. Okay.
Now, for adding, we need to find the LCM of the denominators.
See, one thing you fix there in. Okay, let me draw and give you some more hint. Mixing means like this, if you get it. So this all are E. Same way we have like this. We have so many. We have rows and n number of cells. Internal resistance R, and one external resistance we are giving current supply here, external R. Now you think and tell me. Let's see. Are you getting some idea? Doesn't matter right or wrong, but I want some idea from you. Because if you keep thinking, then only it will be increasing your thinking capacity. You can think out of box someday. Yes, anyone want to try? Or shall I call by name?
Yes.
Yes, Krishna, try. What do you think? What's your idea? What will do here?
Yes, sir. Instead of we have took one resistance, sir. Instead of all the batteries,
Yeah, all the
we can
batteries.
combine it into one.
Okay, how we will make it? How will
No
how will
idea.
combine all that? We have this many batteries. How will combine?
So why to use those many batteries?
No, this is just n numbers. We don't know. N numbers can be 2 also. N numbers can be 1 also. It's 1 to infinity. Anyone else want to try? Krishna tried something. Okay, he wants to add all the batteries. Okay, what else we can do? Come on, guys, come up with your
Take common.
ideas. Take common. What is that? Be specific a little bit.
So there are n number of resistances. So we can take one resistance and like there are
Okay,
so many resistances, so we can take one as common. One
you can take x y z value. Okay, tell me x times resistance. Then each row has x times resistance. Then
add the resistances.
add the resistance. Okay, they have y times of column. Then
Add.
how will you add?
Not
See, it is actually very simple. You have to just combine both ideas. You understood this series and parallel both? Guys, you understood series?
Yes, sir.
Okay, so what we did here, n times of r, right? Think, okay, keep thinking. N times of r. Here we did r by n. Now we have to combine both. So how we are going to combine? We need n times of r also, we need r times of n also. But here both n cannot be same. So let's take m and n. So let this number of cells be m cells. And number of rows be n rows. Now something is getting cleared. Net EMF. In parallel, E will be same, whatever value of E we are getting. So first thing, how we will start? Suppose if these all are cells, resistance, what we'll do? First, we will add this, right? See what I'm saying? If I have like this, okay, how will you start? This all are R1, R2, R3, R4, 5, 6, 7, 8, whatever. So what we'll do with this resistance? How will you solve? How will you solve this resistance? They have some values. Okay.
First add
So-
the series resistance and then add the parallel.
Exactly. We'll just first solve this series, this series, this series, this series, then all this parallel. Right?
Parallel. Yes.
Exactly what to do here. See, once I write here, you will think, oh, this was the thing. You're taking so much time thinking. See, I'll just write here. Now in this EMF, I need just series because in parallel EMF will be same. So we will write M times of E. All this parallel will be same. One thing good done. Now net internal resistance. In net internal resistance. So first we need to solve this. So it will be n times of, sorry, not n, m times of R and n rows. So divide by m, not m, n. Right? Parallel formula is R by n. Series formula is nr. So we combine mr by n. Clear in this one? Anyone having doubt? Guys, are you able to understand? I want quick replies.
So what is M, sir?
M is number of cells. So every cell has their internal resistance R. So n m times of R in series. Now those series, if I show you this way, we got here M E M E N M R. Here also M E and M R till n times. So these are n number of rows, 1, 2, 3, 4 till n. So this total R. So now your resistance is MR. So 1 by MR plus 1 by MR plus 1 by MR plus so on. So it will be n times of MR. So 1 by R. R equals to MR by N.
Yes.
Clear? Same thing what we did before, same thing we are doing, but a little bit extended manner. Instead of numbers, we have alphabets. Clear?
Yeah, sir.
Others, are you able to understand or shall I explain again? See, this is new for you. So you can ask, like, I didn't understand, I want some more explanation, whatever it is.
So can you explain the N, sir?
N means, see, this is suppose number 1, first row. First row, second row, third row, and this is nth row. This is n. So what we did in this parallel, see that we did here n, right? N cells. We did here n cells. Yes, it is like maths. We have nth term. Yeah, correct. So it is nth cell, nth term. Okay, so if you want me to write here, this, okay, I will write this one more. Not here, I'll draw here. This is ME, and it has MR internal resistance, MR. same values till we have nth row like this. Nth row of ME values. Nth row of ME and MR value. So for all this combining, what we are going to do, we'll just combine those resistance, and EMF will be same. EMF will be ME. Resistance will be 1 by R, total resistance, net resistance equals to 1 by MR plus 1 by MR plus so on till 1 by MRN, nth term. So we will add like this n times of MR 1 by R, and reciprocal of this net resistance, internal resistance will be MR by N. See, make a note of this one, then you will remember.
Yes, sir.
Okay, this is not yet over. Those who completed, find the value of I. Now this is very simple now. I equals to V by R. So here V is ME by R plus MR by N. So MNE by NR plus MR. This is your I. Okay, I'll scroll up. Those who didn't finish writing can write. M is the number of cells and N is the number of rows. Done writing? Do you need anything here? Everyone understood? Aditi still not there? Understood? Okay.
So can you share this notes PDF in Google Classroom today, sir?
Yeah, I'll share this.
And even last classes and the recordings.
Recording I didn't post. I posted, I think so. I posted recordings. Please check and tell me.
Yes.
Just check the recording dates and tell me, like, if it is not there, then I will check.
Yes, sir, sure.
Krishna, understood? Any doubt in this one? I cannot hear you, Krishna.
Yes, it's cleared.
Okay. Deepshika,
Yes, sir.
Harini,
Yes, sir, clear.
clear, right? Okay.
Yes, sir,
Shreyan,
done.
Sir,
clear. Any doubt in this one?
no, sir, no doubt, sir. I'm clear. Perfect.
Okay. Amatullah,
Sir, can you explain EMF, sir? Let me know.
EMF in the sense summation of EMF.
Yes.
Yes, sir.
Yeah, it's simple actually. See how we are adding this as in series, how we added, same formula we are going to follow. In series, what we did here, see, where is EMF? This one. In series, we simply added this, right? N times of E. E plus E plus E plus E, so till N times. And in parallel, it is common. So we are not going to do anything there because in parallel, voltage same, only current differ. So EMF in parallel will be same. So here in mixed grouping, we are getting our common value is ME. So ME in parallel will give you same value. ME in total EMF.
Yes. And the definition. What is EMF?
Electromotive force. It is an electromotive force. Anyone else doubt? Mohit? Yes, Kavya?
No doubt. No doubt, sir.
Okay. Nitya? Pranav? Satvik? Sharanya? No doubt, right? Udbhav, Ujjwal? Yes, Sharanya? No doubt, right?
No.
Okay.
Yes, sir.
Okay. And Ritvik? Okay. Now, what's the heating effect? Or if I give a name like Joule's heating effect. What is Joule's heating effect?
Sir, when electric current is passed, heat is directly proportional to the square of current within a given time.
Yes. Proportional to resistance and proportional to time. So H equals to I square RT. So actually no need to remember this formula. We need to remember P equals to
VI.
VI. Another form, P equals to
I square
R. Another P equals
V
to
square by R.
V square by R. These are power formula. Those who don't know, make a note. I will write it properly. Power equals to work done by time. So for getting work done, V equals to W by Q. So V Q by T, and Q by T is I. So we got P equals to VI. Now we can, by the different formulas, V equals to IR. By V equals to IR, we can get P equals to I square R. Another one, P equals to V square by R. So heat equals to P into T. So if you remember, this one is enough. With P, we can use any of this formula, VIT, I square RT, V square by RT, or VQ. Another H equals to VQ. Power equals to work done by time. So, okay. So what are the unit of power then? Let's write unit. Done writing? Shall I scroll it a bit? Or okay, let me write here itself. Power is joule per second, which is what? Now heat. Heat is energy. Energy or work done. That is joules. Heat unit is joule. Done writing?
One minute.
Yeah, sure. I'll give you one
Yes,
mind map. I'll take a screenshot here and send you so that it will be easily you can remember everything. Okay. Any doubt to this class?
No doubt, sir.
Revise whole chapter
No
and
doubt,
come.
sir.
Okay. Revise everything till now.
Yes.
Okay. Guys, everyone.
Yes, sir. So in the next session, you're going to start a new chapter, right?
I'll do some numericals first, which I didn't complete those numericals, like typical numericals. Then I'll start new chapter.
Yes.
Okay.
So what are you planning to start?
Light.
Okay. Sir.